Hi everyone, I was just checking a local Chord Electronics dealer and guess who I found? I found Rob Watts. Welcome Rob.
It's great to meet you again. It's
big pleasure and a big honor.
First time I've been in Romania and Bucharest.
Welcome.
So I'm really pleased coming here. And tomorrow we've got some dealer events, so it's going to be really interesting.
Big day.
Talking to people. So
lots of people.
Yeah, it's great.
If you don't mind, I would like to ask you several questions about the past, present, and future of Chord Electronics.
Sure.
First of all, I would like to know how was your flight, and if you used your battery-powered TT2 and M Scaler as you usually do.
Yes, I did, and I'm rather pleased actually because I got a new power bank, and the previous one used to last for about 4 or 5 hours, and you then have to find somewhere to plug it. Now it's fine for the Romania flight because it's only 3 hours, but often the flights to Asia or Los Angeles, you're talking about 13 hours, and this little beast can do 10 hours. So I'm really quite pleased with that.
Do you have a photo of that setup? I'm really curious how that
I can get you one. Yeah, because I've got it with me in the hotel room.
And you have a portable player that outputs digital
So
signal?
what I use is my mobile phone, and it's got a 1 terabyte memory
offline music. Okay.
On there, so I've got plenty of music and
you output via USB or
USB straight into the M Scaler and then into Hugo.
Wow,
and then I use the Dan Clark Audio Stealths, which are really good sounding
closed back headphones, right?
Closed back, so you
can use them in the flight.
You have to use closed back for flights, really. I tend to prefer the sound of closed backs, which is a bit strange because most people say they prefer open back headphones.
I prefer open back, yeah.
But you get better precision, lateral position. You get better sense of depth with closed backs, certainly with Dan Clark's closed backs.
Okay, I need to try those, that's for sure.
The Stealths are really something special.
Okay.
And I didn't appreciate, when I first bought them, and I didn't hear them, I just said, I want a pair, send me a pair. So they sent me a pair. And I was, really impressed because they were a lot better than the Eons. I didn't realize how good they were until I started doing my own recording. And I used the Stealths on the recording session. So we'd play acoustic instruments, do a recording on a practice session, and then play it back when they'd finished with the Stealths.
Okay.
And it was surprisingly close to the sound of the original. This is using M Scalers, Hugo 2s to reproduce the recording. I was using Blumlin recording with Rebin microphones, so it's just a stereo mic straight into the A to D converter. No mixing, no processing, nothing.
Yeah,
just raw. And so you're getting as close as possible to the original, recording. I was surprised how accurate in frequency response it was against the original. In fact, the big surprise was that the digital sounded warmer and softer than the original. So the original is sharper and brighter than the digital reproduction. And these are using Stealths, and I'd already put Stealths as being a little lean sounding, a little bright sounding, but compared to live recording, and of course we're not listening to the Stealths, we're listening to the Stealths, we're listening to the Hugo, we're listening to the M Scaler, we're listening to the A to D converter. The A to D converter itself has got a softening sound to it for various reasons. And the ribbon microphones that I use, depending on where you place them, because ribbons, you get a different frequency response depending on how close you are. They can sound a little bit warm. I was really gobsmacked that this thing was so accurate.
Now you're making me very curious about those stealth. I need to
You need
try
to try them out. Yeah.
I'm curious, what are your favorite loudspeakers and headphones and why?
So we've covered the headphones.
So that is your favorite?
That is the favorite. I've not come across a set of headphones at any price that outperforms the Stealth in terms of soundstage depth, lateral precision, and the ability of when things get busy. Normally headphones tend to fall apart and sound a bit congested, and the Stealths don't tend to do that. So they're very linear sounding.
Interesting. I'm curious if you ever tried the Mesa Elite, the Romanian one?
I have, but only very briefly, and that was prototypes when they first came out. It was about 3 years ago.
Maybe 2 years, something like that.
Yeah, something like that. And I tried them, and I thought, okay, they're nice, but they didn't have that quality that I thought, this is something I need to investigate.
But did you ever try something like Half a Monster's Barra?
No.
Those are very hard to drive. They need gobs of power.
Oh, okay.
Sometimes even something like a power amplifier to drive. But transparency and detail retrieval, wow. Yeah. It's something else entirely.
Yeah. So going on to loudspeakers. Yeah. I mean, at home I use BMW 803 D3s.
Oh, okay. So something
a little bit smaller than these. Okay. And it was funny. The reason I ended up selecting a speaker selection is a bit difficult because,
of course, you have the room acoustics.
You have the room, and that's how they interrelate and all that kind of stuff. But we were doing a show in Tokyo, and the distributor had set things up. And what they did was they had some reviewers coming in. Okay. And the reviewers were highlighting how the sound quality of this very strange way of doing things. Yeah, I agree. Japan is very different to the rest of the world. I agree with that. So the reviewers were coming in and highlighting the differences, and playing their own music. And we had lots
J-pop.
Yeah, we had no, it was all good stuff. Okay. And we had lots of different music, different reviewers coming in, famous reviewers within the Japanese magazines. And it had the 803s, chords. It wasn't the Ultima, it was the one just before the Ultima. Because I can't remember, recall. Yeah. Dave feeding it, and an M Scaler. And normally, hi-fi demonstrations, things do not sound as good as your own system back at home.
Of course.
And partly because you're used to that kind of sound. But this one sounded incredibly good. Really deep depth. And it was very musical and very involving. And I thought, oh, this is something special. So I ended up...
I see a pattern. You really like depth, soundstage,
and depth is very important.
For you, it's very important.
At the end of the day, it's about listening to the music, getting emotionally involved with the music.
Of course, that's the most important.
Getting your spine to tingle.
Oh, that's the most important.
That drug is what you're trying to get. And what I've tended to find is that if it doesn't have decent depth, it will not work for me emotionally. Yeah. I mean, there are lots of other things that go on with it, like can you hear the transients?
Yeah, I agree.
Is there a timbre variation? Is there a variation in space? When the sound gets large and busy, does everything collapse, or does it still sound where very tiny instruments you can still hear in focus against large instruments?
I agree on that.
So if all those things happen, and the musical performance is good,
everything just clicks.
Bang, it clicks.
Yeah, I agree.
And that's the buzz I'm trying to get. And one of the interesting things is that if you play a recording, if it's got good depth, it might work.
Yeah, I agree.
If it hasn't got good depth, forget it. It's not going to work. So
try something
depth is one quick way of finding out whether something works or not.
I agree with that. I currently upgraded to a Chord DAC, Ultima 3 preamplifier and Ultima 5 power amplifier, and I'm really wondering if I can add somewhere in the future maybe a wireless streamer made by Chord Electronics.
That would be something that Chord would do.
Okay.
So streamers is not something that is something I spend a lot of time on.
But it's still digital, you know,
Yes, but
a digital transport.
I focus my activity on things that are going to improve the sound quality.
Okay.
And now, of course, when you plug in different streamers, you get a different sound. But the reason you're getting a different sound is the sensitivity of the DAC, assuming the streamer is giving you bit perfect data.
Yeah, yeah.
So if you're getting bit perfect data from the original recording, then the difference in the sound is not the streamer, it's actually the sensitivity of the DAC.
Wow.
So if I do my job properly and have the perfect DAC, it will make no difference what source you're using. They would all sound the same. So I could spend a couple of years developing a streamer, but it's not something that's going to improve sound quality. My focus is on improving sound quality, and to me that would be, let's make the DAC much more tolerant, so that you can put in a crappy source or a very high quality source and they sound the same.
I agree with that, because Dave sounds great even with optical, let's say even from a TV.
Yeah.
But if you put a wireless streamer, it sounds a little bit cleaner, a little bit better. So, you know, just an idea for future. Maybe something like can be done about that.
Whether Chord go ahead and do a streamer, that's up to Chord.
Yeah.
But it's not something that I'm interested in doing.
Okay. I'm personally using loudspeakers and headphones, and for me both, you know, very, very important.
Sure.
For me it's something like 50-50. So in my office I use headphones, and in my living room it's only speakers. And I know that Chord has high-end and ultra-high-end integrated and power amplifiers, but not so much, or just a little guy headphone amplifier. I'm wondering if they will ever make sometime maybe a high-end headphone amplifier.
Okay.
Something that can drive anything, you know, even hard to drive headphones like planar magnetic headphones, for example.
So the downside to having a headphone amplifier is that you've got separate set of cables, interconnect cables.
Along a signal path.
Yeah, another signal path. You've got another set of electronics in the way. That will always degrade the transparency.
I agree with that.
And you can never escape that. So my approach is to make the DAC itself as powerful enough to cover any headphone eventuality.
Okay.
And that's why with Dave, 99% of headphones is perfectly fine.
I agree with that.
But
yeah,
there's still that 1%.
Yeah, crazy dudes like me.
Dave would not be able to drive.
Yeah.
And that's why with TT2 you can see the approach that I've got, where you make it much more powerful. That way you do not need a separate headphone amplifier.
Okay.
Because the power is innately in there. And having it that way, you get the simplest analog solution. It's a little bit strange with digital electronics, because with analog electronics, the simpler you make it, the better the sound.
I agree.
So each soldered joint, you can hear a soldered joint.
Is degraded
each
a little bit.
metal to metal transition, you can hear it in terms of depth and detail resolution.
Yeah.
Each amplifier you add seriously degrades the sound quality. Every passive component, a resistor, a capacitor, will degrade the sound quality. So if you make them simple, as simple as possible, without it breaking and without having obvious other problems,
Okay.
it's going to sound better. With digital, that's not the case. And people tend to think of digital as being the same as analog, in that we must have a simple digital data path. Hence NOS DACs.
No oversampling.
No oversampling. No oversampling actually is the wrong term, because it is oversampling.
Yeah, the newest ones are doing oversampling.
All DACs that
especially
just sample and hold.
Yeah.
That's a first order filter. It is a digital filter, and it is oversampling. because all it's doing is maintaining the data and keeping it, and that is a simple type of filter. So even a NOS filter is an oversampling filter.
Yeah.
And you can't escape that because digital is sampled data. It must be converted into continuous analog waveform. That is an infinite amount of oversampling. That's what's happening.
Yes.
Whether you're doing it in the digital domain or the analog domain, you're still doing it. So everything oversamples. Even a NOS DAC is still an oversampling DAC. It's just the crudest, simplest filter you can get. So the thing about it is that with digital, the more complex it is, the more accurate the reconstruction, in the case of a filter, the better the sound quality. And that is really bizarre. Because it's completely the opposite of analog. It's all about accuracy. And in fact, the situation with analog and the situation with digital is the same. It's all about accuracy. It's just with digital, to get it accurate, it must be very complex. With analog, to get it accurate, it must be very simple. And people should focus on accuracy, not on whether it's simple or more complex.
Yeah, I also agree with that. I know that you're a big fan of FPGAs, so you're working with them for decades, Xilinx, Spartan, Artix, all those silicon. But I'm wondering...
The first FPGA that I used was back in 1990.
95?
No, we were using, maybe it was 1992. We were using very simple Actel FPGAs. And these were curious devices because they were anti-fuse FPGAs. What happens with an anti-fuse is that you've got a blank circuit, and the anti-fuse, weld the constructs together by putting a big voltage through, and you program the chip up, and then it would end up being, the hardware would be implemented with metallization that you've done through this blowing process. So it's anti-fuse because it's the opposite to a fuse. It's actually making a connection when it's got a lot of power going through it. And the great thing about it was that you plugged it in, you had your hardware circuit working. The digital circuit was working perfectly. The downside to it was that if you wanted to make a change, you had to buy a new FPGA and program that. So making changes was a real problem. So I started using them in '92, and that was very simple. That was just using lots of different dither and feeding lots of different noise shapers with different dither data, and then summing them together in the analog domain. And then in '95, the FPGAs, anti-fuse FPGAs, became big enough to do a noise shaper. My own noise shapers, and that's when I created Pulse Array and the SPDIF receiver. So we had one for the SPDIF receiver, a couple of them for the noise shapers, an external silicon filter, interpolation filter. So that was in '95. And then in '99, when I started consulting with Chord, the Xilinx FPGAs became available, and they were super powerful by comparison to the Actels. And that had enough processing power to do the interpolation filters as well. And
that's when you started making...
That's when I started doing everything within the digital domain. It's been an interesting journey. That 10 years, when I think about it, I started off, 1989 was the first DAC that I designed using Philips chips. And by 1999, I was designing with FPGAs, doing everything within the digital domain. So that's quite a fast. And at that time, I knew nothing about FPGAs. Had only just been invented. I knew nothing about digital circuitry, and everything was kind of self-taught. So that 10 years was quite a big change.
I first tried Chord DAC 64, I believe.
DAC 64. That was
many years ago, and I was just blown away.
Yeah, and that was the first WTA filter.
And I bought it that time. It was, something else.
You don't look old enough.
I'm 13. But I'm really curious if you ever tried working, or maybe with R2R ladder DACs, or maybe
Sorry, with them?
R2R.
Oh, R2R DACs.
Resistor to resistor ladder DACs.
Okay, so
And what you really think about the oldest
going back
digital
to 1984 and up to 1989, the DACs were all R2R DACs.
Yeah.
And they sounded dreadful. Absolutely dreadful. Vinyl was so much more musical, so much more engaging, and digital sounded flat and hard. And they were using R2R DACs. And then Philips in 1988 launched the Bitstream, which turned out to be the same as DSD 256.
Wow.
And when I first heard the first version of this, and it was very simple, second order noise shaper, 1 bit, 256 times, I was just blown away, because it's the first time I'd heard digital actually sounding musical, smooth, and more like my analog.
Yeah.
That's how I got into it. But then I soon recognised there was problems, which is why
you have the ladder, hundreds of resistors and so on.
No. With the Bitstream,
with the chip,
there was problems, and I couldn't get around my head. You've got 256 1-bit pulses. How is that good enough to describe a 20 kilohertz waveform? And there's just not enough pulses there to do it, and that to me intellectually made no sense. And then I started playing around with my own noise shapers, using mathematical models and playing with it, and understood how the noise shapers worked and all that kind of thing. Saw some immense problems, and first FPGAs was using dithers and lots of noise shapers and paralleling them up, and that made things sound better. But it was an improvement that said to me, we've got a problem here. We still need to improve things, and that led me to developing the pulse array DAC technology and all that kind of stuff. But going back to R2Rs, there are fundamental problems with R2R DACs, and the basic problem is that you can never get the resistors to match. That's one fundamental problem.
The biggest one, probably.
The other fundamental problem is that you cannot get it to run at very high speeds, because the FETs need to switch, and you can't get the FETs to switch fast enough. So the fastest rate of operation is 16 times oversampled. And when you're running at 16 times oversampled, so you're trying to reproduce a 300 kilohertz sine wave, with R2R DACs, it's a mess. It's highly distorted. One of the things that I've found is that the ear is very, very sensitive to high frequency noise and high frequency distortion. And I agree
with that.
I've seen distortion at 10 megahertz being subjectively important.
But 10 megahertz, it's way...
Yeah, it doesn't make any kind of sense.
You
can improve your distortion performance in the digital domain at 10 megahertz.
And it will have an impact.
And it has an impact. It's down to aliasing and noise floor modulation, but it has a very big subjective impact. So some of the things that I'm doing is improving the transient performance and getting the transient accuracy correct.
I like transients. My favorite transient response.
But what is important with transients is that even when you're running at 50 megahertz or 20 nanoseconds or 10 nanoseconds, the performance at 10 nanoseconds is critical to the sound quality. And R2R DACs, you
don't have that timing.
You don't have that timing. You can't do it. It's just physically impossible. So there are fundamental limitations with R2R DACs.
So we're talking about switching mode power supply.
Switch mode power supply. So, if you'd asked me in 2014 or 2013, what is the best power supply or regulator? I'd say linear, because of course it's not switching.
Makes sense.
And switching is something you don't want because it's going to create RF noise, and RF noise is something that causes noise floor modulation that makes things sound brighter. And you don't want it to sound brighter, you want it to sound smoother and more natural.
Okay. Yeah.
So that was something I knew about, and instinctively I didn't want to use switches. But with Hugo, you've got to keep the power low because it's battery operated. So imagine if we've got 1 amp at 1 volt, and that's to feed the FPGA core, and it's an 8 volt power supply. If you're using linears, then you're going to have 8 watts being dissipated in the circuit.
Really
that will get impossible. You can't do a portable product.
Yeah, I agree.
The battery would disappear, and the unit itself would get unbelievably hot. The maximum we can do in a Mojo style unit is 3 watts. If you go above 3 watts, it will get too hot. With Hugo, it's about 4 watts, something like that, that we can dissipate, and that's just a physical size problem.
Yeah. Mm-hmm.
And you don't want to put fans into a portable product.
Of course.
And then, of course, you've got the issue of the battery itself disappearing. So if you use a switch mode power supply, or a switch mode regulator going from 8 volts down to 1 volt, they're 95% efficient. So you'll be looking at, in total, around 1.5 watts being dissipated.
Yeah, something like that.
So, something like that. So that's manageable and that's perfect. So you have to use switching regulators with portable products. It's just impossible not to. So I plugged these regulators in and listened to them, and I just couldn't believe how good they sounded. Rather than sounding, I was expecting them to sound brighter because of this RF noise and noise floor modulation, they actually sounded warmer and smoother than the linears. And this was very strange because you'd expect the exact opposite.
Yeah.
The thing about switching regulators is you must put RF filters in. RF filters on the input to the regulator, RF filters on the output, because you want to get rid of the switching noise. So you've got to put RF filters in. That helps your RF noise.
So you find a solution, basically.
So, it covers that. The other thing is that if you can imagine 8 watts being dissipated from your 1 volt core, that's going to create an awful lot of noise within your circuit. Whereas if there's only 1.5 watts of noise due to the core, that's much less noise that's going to corrupt everything else. So linears magnify the noise that you've got within your digital cores, and that is something you do not want. And what I've been finding recently is I've been doing SPICE modeling. SPICE is something you use for analog electronics.
Okay, something new for me.
So it's a modeling software. You'll have a parameter for a transistor, a parameter for a resistor. You can model a resistor in terms of its parasitic inductance and parasitic capacitance, and you can plot everything. You can add transistors.
So it makes your work much easier.
So it allows you to design things much easier. So you can, if you want to design a filter, you can evaluate the performance completely. If you want to do a switching output stage, you can design it, characterize everything, and see the switching activity and see what you need to do. A filter, you'll get a complete analysis of what the filter is before you're actually physically building everything. And you can measure. Oh, it's really, really powerful tool because you can measure things at picovolts or attovolts, which you can never actually measure in real life because you'd see things that you can't do. One of the things I've been looking at is the effect of RF filters and improving the quality of the RF filters. And if you start off with I want to filter a switch mode power supply, which is just a regular PWM signal. That's very easy to filter. You can do it with a couple of inductors, a couple of capacitors, job done. You're going to have nanovolts worth of output over the thing. If you use random noise, it's a disaster. To eliminate random noise to below nanovolts requires an incredibly complex filter, and several orders of magnitude more complicated than the filters you need for a regular PWM. A PWM signal from a switching regulator actually doesn't create any sound quality problems, because when it creates the intermodulation distortion, it comes through as discrete harmonics which are related to your switching activity. There's nothing in the audio bandwidth, but it's random noise, random RF noise that creates intermodulation products that's inside the audio bandwidth. So it's the random RF noise that is creating your noise form modulation. And this is the thing that is almost impossible to remove with filtering. So actually switch mode power supplies aren't really a problem in terms of creating noise form modulation, and they actually help because you're having to add extra filters, and that extra filters stops random noise from coming in or reduces the effect of random noise from coming in. So it was those two reasons, better RF filtering and the fact that you've got less noise in the analog section because of this amplification effect of linears, that gave me much better sound quality. So now I've started using switching regulators, and they switch at 3 megahertz, properly filtered. They sound much better than linears. I've been using those ever since, even when I don't need to worry about power supply dissipation, because you get better performance. When you come to switching power supplies, there are huge problems with linear power supplies. And I'm thinking now about power amplifiers. Firstly, the audiophile linear power supplies do not have RF filters built into them.
Yeah, they don't have. You need to filter that after the power supply.
And the kind of filtering that you need to do to eliminate mains-borne random RF noise would be horrendously complicated, because I know from my SPICE modelling, when I was trying to remove everything from 100 kilohertz to 10 gigahertz and using a random source and making it nanovolts level with 1 volt of random noise coming in, it's a horrendously difficult task to do. But they, linear supplies have no filtering whatsoever. So they're completely transparent to RF noise that's coming through. A switching power supply will have a filter on the input and a filter on the output. They have to do that because they will fail the MC requirements and safety standards. So there's RF filters built into it. That helps reduce RF noise from the mains. So looking at it simply, you're better off having a switching power supply that's got RF filters built into it than a linear supply that doesn't. The other problem that linear supplies have got is the 50 hertz ripple noise. So you'll get 50 hertz, 100 hertz, 150 hertz, 200 hertz, 250 hertz.
And you need to deal with that.
And it's there because of the triangular wave, the ripple that's on your capacitors and from the output from the transformer. And the problem with this noise is that when in a power amplifier you're doing a small signal, you get small amounts of ripple. When you're doing a couple of 100 watts, you get a large amounts of ripple. And so the noise in, from 50 hertz to 10 kilohertz increases, and it increases with the signal. So you've got this low frequency noise that's pumping up and down with the music signal itself, interfering with the music signal, and it's got a very high frequency content to it. That is very, very audible. And you can see the measurements. It's pretty awful from a measurement point of view, but from a sound quality point of view, it's
even worse.
It's much worse. And it's the sound quality that's important. Measurements don't matter.
Yeah.
What's important is the sound quality, and the measurements are used to reduce your problems that you've identified. This doesn't happen with switch mode power supplies. With switch mode power supplies, the nature of the beast means that your 50 hertz, 100 hertz outputs are fundamentally much, much lower. And it doesn't change with signal level in the same way that linear supplies do. So switching power supplies are much better from an RF point of view.
I'm now a believer.
And from this low frequency grunge point of view. But it's something that people always think, well, linears must be better.
Especially older people, old school files, you need to have big transformers, otherwise it will not sound great.
But it's not true.
I have a follow-up question about the switching mode and linear transformer and so on. There are several third-party companies which started making linear power supplies for M Scaler, for TT2, for DAV, even very expensive. What are your thoughts about those? Are those really good? Are those really changing anything and making things better?
Okay, so I can't talk too much about Dave because Dave, when I designed and developed Dave, we had the switching power supply, and that's what we used, and I just used that. And I knew they worked well because we'd used them before. We didn't have any measurement problems, no noise source modulation, no 100 hertz issues, so I was happy to use it. There's lots of RF filters built into Dave. It's got a very sophisticated power supply arrangement internally, so I wasn't too worried about the quality of the power supply. With TT2, we this business about linear supplies was cropping up, and I spent a lot more time on TT2 and with Q-Test DAC as well.
Yeah. Mm-hmm. Small one.
With 2Q around 2016, people were starting to use linear supplies with it, this is one of the ways, an illustration of some of the ways that I work and why the forums are really useful for me.
Exactly. Mm-hmm.
Because with Q-Test, people could hear differences with different power supplies. And I thought, I've got enough power supply rejection here.
Yeah.
It's a sophisticated power supply arrangement. It shouldn't make any difference. So I tried messing around with it. Didn't mess around with linear supplies. I messed around with the best supply you can get.
Well,
and that is a car battery. Okay. A car battery has no RF noise because it's not connected to the mains, so there's no random RF noise. It has 300 amps of delivery, and it has 1 milliohms or less than 1 milliohm output impedance.
So very small.
If you measure a car battery, it's a short. On the audio precision, it is the same as a short circuit.
Wow.
So the noise that you measure from it is identical to the audio precision noise when you're doing a short circuit. It is the perfect power supply. People forget this, that a car battery is the reference power supply. Forget about linears or mains. If you want to find out your reference, the best power supply possible, it's a car battery.
Okay, I need to get one.
You have to get. So the beauty of the Q-Test was that it was 12 volt input. So I could use a 12 volt car battery, plugged it in, tried it. After receiving all of these reports about linear power supplies being better than the supply that we supply, and I was gobsmacked.
It sounded better.
It sounded so much better.
So much.
It was a huge difference. It was not small difference. It was huge.
Wow.
It was warmer, smoother, faster, better focus. Everything was better about it. So I thought, okay, this Q-test,
Makes any sense.
it has got problems with
Yeah.
the power supply. It's sensitive to the power supply. That doesn't mean that a linear supply is going to be better than a switching supply. I'm not saying that. I'm saying that there is a sensitivity there. So what I had to do with, sorry, that was 2Q. What I had to do with Q-test was to improve the internal regulation, improve the RF filtering, improve the regulation, so that when you plugged in a switching power supply unit and compared it to the 12-volt battery, my intent was to make them sound the same. And with Q-test, I managed to do that. So the supply that we give with Q-test is the same as sound quality wise as a 12-volt car battery. That means it's the ideal supply.
Yeah.
And if you hear changes when you plug in a linear supply, you're hearing degradations because it's not as good as a 12-volt car battery. And that is possible because they don't have RF filters on the linear supplies. With TT2, we've got an even better option, because if you're playing it and you plug it in and out, you can run it for 10 seconds without the power supply being attached, because it will run on the supercaps. And when you plug that in and out for 10 seconds, you can't hear a difference from the switch mode power supply.
Maybe there is a small one, but
it's very, very tiny.
Okay.
So that proves it's an ideal supply. I went through lots of different supplies with TT2. We had lots of different switching units that I evaluated. All of them degraded the measured performance. And that's when you're looking at a 100 kilohertz bandwidth and you measure the dynamic range with 100 kilohertz bandwidth, and you see the degradations due to the switching activity, which is around 70 kilohertz, except one. And that one made a half dB degradation. You can just about see the switching activity. So that's the unit that I used, and of course I listened to it and it sounded the same as your car battery. So people complain about TT2. It's a cheap power supply. We shouldn't be doing this, and it's about perceptions. It's not about your actual performance.
I agree.
And all I care about is the actual performance. And if it's as good as a car battery, which is the perfect supply, then it's good enough. So people can buy linear supplies, and they will hear a difference. In the case of TT2, it's, to my way of thinking, it's a degradation, because I know it's as good as a car battery.
Still, there are many companies that are making third-party power supplies, even from Dave.
Exactly. Now, Dave's a different story, because this is something that I haven't done the battery test with Dave, because that's a much more complicated supply. It's plus or minus 15 volts and 5 volts.
People put free power supplies in the
I
different voltages.
know.
Crazy.
Yeah.
And there is a difference, but I need to try for myself. I really don't know what to expect. Maybe there should be a difference, but I don't know if it's a good one or better.
The key, if it's brighter or more transparent, it's a degradation.
Yeah.
If it's warmer, softer, smoother, it's a benefit. And the reports I read, some people say it sounds a little warmer, and some people say it sounds brighter. Whenever I hear brighter or more transparency, warnings, bells go off in one side of my head, thinking that you're preferring distortion. People get enthusiastic about trying these things, and they may be making an improvement, or they may be not, and you've got to be very careful.
Some of those are very expensive.
Yeah.
I know that you are a big fan of the BNC digital input.
Yes.
You have 4 of them on the Dave, so clearly you're a big fan of BNC. But I'm very curious if we will ever see I2S or I2S inputs on future Chord DACs. it has the potential, I don't know, but it has the potential to being very good, maybe the best digital input, if only somebody would standardize it. Hint, hint.
So, why do you think it's the best?
Because you don't have a digital receiver. So you have the data that goes directly into the DAC chip. You don't have the DACs that have a chipset.
Okay, but you still need to process the clock.
That is
And
true.
it is the processing the clock that's the problem. So if I get an SPDIF data, it goes into my SPDIF receiver. That converts it into I2S internally. So inside the FPGA, I've got I2S lines coming out. I've still got the problem. What do we do about the clock?
But you have a really good clock at the digital transport. And you have a really good clock inside your DAC, they might sound better.
Yeah, but it doesn't work that way. It doesn't work that way. It's you still got to convert an asynchronous clock with a synchronous clock, and the problem is that process, how you're actually processing that. It's not about the number of lines, because in an ideal world, you could have a very highly jittery and noisy clock input. It doesn't matter whether that input is a direct clock input or via an SPDIF decoder. It's still the same, it's still a jittery signal. My digital phase lock loop manages to strip out all of that activity and noise and problems and eliminates the issue. But that took a long time to perfect. And it took about 6 years to develop the digital phase lock loop so I could get it so that it was actually right. Going back to the earlier DACs, we had a big 4-second buffer. And the input data would come into the buffer and then come back out again.
So it doesn't matter the speed.
So it doesn't matter the speed coming in, as long as it was roughly 44.1.
Yeah.
It would go in and be clocked back out again.
Yeah.
Clocking back out the data out was with the local synchronous clock.
Okay.
So you don't have to worry about how jittery the input was, because that's just data that's been going to the memory. And a 4-second buffer, you'd eliminate the issue. What I was trying to do was to get the digital phase lock loop to work so that it sounded as good as that arrangement, which is the ideal arrangement. And I managed it. After about 6 years, I managed to do it. So the input source jitter, it doesn't, and from a measurement point of view, I can put 2 microseconds worth of 1 kilohertz jitter in, and you can't see it on the output. And I can see down to minus 160 dB. You don't get any sidebands at 1 kilohertz with a 1 kilohertz jitter. And 2 microseconds is 1,000 times bigger than the jitter you will get in real life.
Okay.
So the jitter issue has been solved, so therefore you don't need to have a slightly better clock. You're still going to get, even if you have an I2S clock, it's going to be a bit clock, which is 64 times your input sampling rate. Your master clock that's within the DAC is going to be running at a different rate. In my case, it's 2048 times FS. So it's a completely different rate anyway. So you can't use the bit clock for anything meaningful within the DAC itself. You've still got to convert your clocks. And the fact that I'm extracting the clock from the SPDIF makes no difference. So there's no benefit in doing that. In fact, you could argue, having 3 cables, you've got 3 sets of grounds coming through. You're going to create more noise coming through. And my preference on the source input is always optical. And
that's a surprise for me.
Yeah, always optical. Okay. The reason we use BNC with the M scalers is because I've got the galvanic isolation in there. And that almost gives, it doesn't quite give us, almost gives you the same performance as optical because of the galvanic isolation. It's not as good, but that's another story for another day. But a traditional BNC connection where there's no galvanic isolation, optical is a much better connection. Followed by USB, because of course on the tabletop and Dave, we've got galvanic isolation on the USB, so it's isolated.
Yeah.
But optical is the primary reference input.
Yeah, but it's limited at 24 bits.
24 bits.
192.
192. But then how many recordings have we got that's
you're right.
more than 24 bits and 190? You know, I don't have any.
There are many DAC makers that they put I2S as their best digital input.
Yeah.
You know, and they're
But
trying
then
to push that.
they haven't got the benefits that I've got with the digital phase lock loop.
No, they don't.
So they haven't solved that issue.
Yeah.
I mean, oh gosh, when I used to use analog phase lock loops, it was a nightmare. I mean, we'd have every single DAC would measure differently. You'd have lots of other issues. Each DAC would sound different because of the analog phase lock loop. So using analog phase lock loops to go from your 64 FS to whatever frequency you're using within the DAC is a nightmare. And it's still sensitive to jitter. It creates extra low frequency jitter as well, which is a kind of noise fall modulation problem, which makes it sound harder. So analog phase lock loops are a huge problem. The best way of resolving that is to get rid of them. But then you have to have a more complex solution to fix your problems.
Yeah. Okay, Rob,
Okay.
One last question. How many years did you spend designing and fine-tuning the Dave? Because I have a feeling that something is already cooking. New FPGAs, some time passed since Dave release.
Yes, so there's been a lot that's happened because Dave was 2.5 years under development, and when did we launch it? 2015?
Yeah,
Something like that.
Yeah.
So it's something that I was working on for a long time. What I tend to do with projects is to work on it, get it to the best that I can manage with the hardware that I've got in mind. Test it, listen to it, test it, listen to it, make the changes that need to be changed, perfect it and get it as close to optimum that I can get given the size of the FPGA that we've got in there. And then the project is finished and I move on to something else. The reason I don't make constant changes and upgrades is because I just don't have the time to do that. And commercially, it doesn't make any sense.
And people really hate when you have a new DAC and then next year you need to buy another DAC. I really don't like that.
Yeah, or even updates. You know, some manufacturers produce firmware updates and the sound changes and then it changes again and then it changes again and then it changes again. And each one is a different flavor of sound, and it's, to me, that's not right. That's not the right way to work. I get the best that I can at that moment in time with the knowledge that I've got
and you
available.
go with that for many years.
And then you run with that. When Dave came out, I had a big argument with John Franks because I said to him, we're going to have to replace it in 3 years. And he said, no, I don't want it. I want it to last at least 5 years. And I said, you're effing crazy. You can't expect a digital product to last, high performance digital product to last for 5 years.
5 years. And yet?
And now we're on the
eighth
eighth year.
Yeah.
And it's still the best DAC that you can get your hands on. It's been a fun experience. But yes, I am working on a much more expensive reference DAC. So that's going to be really interesting. I've been reluctant to do I don't know what the price is going to be on this thing, because the way I tend to work, the way I worked with Dave, for example, was that I went for a particular performance level.
And size.
And size.
Yeah.
So it's constrained by the size that you've got, but it's a sound quality and technical performance that I'm looking to achieve. And I don't care how much it costs. In the case of Dave, I didn't care how much it costs because it was just about the quality. And the same is applying with the Ultimate DAC. It's about the performance, and if the price is £20,000, £30,000, £40,000, it'll be what it needs to be, based on the margins and how much it costs to produce. And I'm not bothered about what it's going to end up being. So we don't know what the price is going to be, but as I said, it's all about the performance. So it's engineering driven. And there's a lot of components inside the unit, as I mentioned earlier. Yeah. It's going to be quite a beastie.
Can't wait to see it and to hear it, especially.
Yeah.
And one last question: Guinness beer or IPA beer? What's your favorite?
I like golden ales.
Golden ales.
So I'm not keen on IPA. I like Guinness, but Guinness you can drink one pint. And then you're done. But IPA, it's a bit too citric for me. So I tend to like golden ales. But
maybe we should get some golden ales.
Oh, absolutely,
yes. Talking about audio, that would be great. Rob, thank you for everything.
Thank you
very much. It was an amazing time. You are a great person, and thank you everyone for watching. See you next time.
Thank you.
Bye.